Hey Bjorn, my name is Ripon Dorimon. My student ID is 10151792. Today's video is about our assignment 3, and in this video it is like three part, and here is a part 1 who- where first of all I have solved like a 45-degree line detection. To detect 45-degree diagonal lines, I used a convention current design to highlight patterns from bottom left to right when applied in the image, and these kernels precise pixel that follow 45-degree directions and suppress all directions. And here it's 135-degree line detection. To detect 135-degree diagonal lines, I use the kernel that highlights patterns from top left to the bottom right. This kernel responds strongly to pixels aligned in the 135-degree direction and helps identify diagonal edges. And this the part 2 is about edge detection. And first one is the first edge detection kernels highlights the area where there is a strong changes in pixel in intensity, and those changes usually represent edges or the boundaries of object in the images. And second one is and second kernel data detects edges in specific detection, such as horizontal or vertical edges. It emphasizes a certain orientation of edges in the image. And third, the kernel detects edges in another variation or direction. It helps extract different types of features, allowing comparison between multiple edges detection filters. And this is the part 2, where I import in libraries, preparing data set, and building the neural network model, as you can see, and custom callback class for logging, and is the training in the network. Plotting the result, as you can see, has training accuracy and validation accuracy. This is the training accuracy, and is the line for the validation accuracy. And here now I'm gonna answering question 3 to 10. So during training, the neural network learns the pattern from the input data. It makes prediction and compares them with the actual levels. Then it calculates the error using the loss function, and update the model's weight using um, back propagation, and optimize, and over the time the model improves the performance. And it's how many layers in the, and their tabs there. The original model has total 5 layers. Con 2D is a convolution layer. Max plo- uh, max pooling 2D is a pooling layer. Pattern is converts data into 1D. And intensive 128 neurons and urea is a fully connected hidden layer. And density 10 neurons and softmax, which is output layers. As a briefly explains what is the purpose of each of these layer. And here Convo 2D extract input images features such as edges, sharp patterns, and max pooling 2D. It's reduce the size of feature maps and keeps the most important information. And Platen is converts to the features maps into 1D vectors so that it can be used by density layers. Density 128 and reuse learns high levels patterns from extracted features. And density 10 and softmax, which is produce the final probabilities for the 10 images class in graph 10. And here is a 6 number, add extra convolution layer. I added an extra Convo 2D layer to the model. This allows the network to learn more complex features from the image. The additional layer improves features extraction um, by capturing deeper patterns such as the textures and shapes. However, it also increases training time and model complexity. And in 7, it's compare the result between original model using kernel and sequential versus the bigger model that at least one extra layer added. Um, the bigger model performs better features extraction because it has more layers and parameters. It can learn from more complex patterns compared to the original model. However, it takes more time to train and has a higher risk of the overfittings. And question number 8 is added dropout layer to your model, and here it is increasing the size. It's increasing the model size improves its ability to learn complex features, which can increase accuracy. However, if the model becomes too large, it may overfit the training data and perform poorly on new data. And the last question is explain your own. It's, here a dropout layer helps reduce overfitting. It works by randomly turning off some neurons during training. This prevents the model from relying too much on specific neurons and helps it learn more general features. That's everything for this video. Thank you.